Welcome everybody to Rudy's Electronics Lab. And today I want to talk about this edition that I purchased recently, a little microscope, an Andonstar AD409 Pro ES. It's a fairly affordable device at about 300 euros retail price here in Europe. And I've been doing quite a lot of work under a big loupe and even a bigger magnification loupe. And I've been having this wish already for a while to have a microscope, not only to inspect things a little bit better and more close up, but also to be able to use it for recordings for my video here. So I was particularly interested also in capturing output from the device. And already a lot of videos around on this particular device, and normally I don't like to make a review when there are already plenty of videos around, but there was a bit of a thing with all the videos. All these videos that I found on YouTube were very, very positive, raving about the device, and they were saying things like it has like stunning photo quality with 24 megapixel photos coming out of it, top-notch optical performance. People were explaining that you should record on UHD resolution, otherwise the device would downscale. Other people were commenting that they connected it up to a 4K monitor so they could see all the details of the microscope. Also, some people were talking about that the device was suffering from a global shutter. I think they must have tried to refer to rolling shutter. If it had a global shutter, it would be rather a perfect device. But anyway, my own experience when I was looking a bit at the picture quality seemed to be a bit different from what a lot of other people have seen. So I decided to dig a little bit deeper into it and to understand really the way that this device deals with pictures and what you can do with it and what you cannot do with it. And let me say upfront, this is going to be a fairly critical review. So I'm going to try to uncover a couple of things about this device. But even when I'm being very critical in this review, I really think still it's a very nice device. I'm having a lot of fun with it, and I would certainly buy it again. But just bear with me to understand a little bit better what like the actual performance of the device is. And today I'm going to focus solely on the optical side, on resolution, picture and video. And I might do a later video where I actually want to go into a lot of other stuff of the device, but also going to give you some 10 different tips how you could actually improve the device depending on where you're using it for. But today the full focus will be on the picture side, on the optical side. So the questions I'm going to try to answer at the end of the review are, so what is the actual resolution of the device? And I'm talking of the combination of the sensor and the lens, which are connected to each other. We cannot disconnect them here. What are the best settings for capturing pictures and videos from the device? What settings in terms of frame per second are being useful here if we do video stuff? And does it make any sense to connect this device to an external monitor for reviewing what you're working on? Now, that are the 4 questions that I intend to answer here. Now, the fact that people talk really about this very high resolution stuff, etc., going on, probably comes from the fact that if we go into the menu of the device, we have a wide choice of different resolutions that we can store our photographs with on the SD card. And as you can see here on this device, you got these 2 menus here, or 2 pages in the menu, and it goes all the way from 24 megapixels pictures all the way down to a 1.3 megapixel picture. So these are all different settings that the device has here. And if you look at the video side of things, we also see a rather wide choice of different type of formats, ranging from ultra high definition with 24 frames per second all the way down to HD performance with 720 lines vertically. So also fairly high resolution type of settings and also a choice of different types of frame rates there. The highest setting, by the way, the UHD setting, I just wanted to note that this is not a 4K UHD mode. There might be a bit of a discussion what UHD means, but many define it as something in which you would have vertically 2160 lines, but that does not necessarily imply it's actually 4K, and in this case it isn't. As I'll show you later, that doesn't really matter because we're not going to get anywhere close to this resolution, but just a note on that resolution part. Now, in order to understand a little bit what we're talking about here, I tried to put together like all the type of specifications of the device that we got here. And since the specifications are rather limited that are shared by the manufacturer, I tried to put things together by measuring quite a bit on the device and trying to see really what all the different aspects are here. And I'm going to show you now a table where I'm going to try to put all of this together. Okay, so here we have it. It is perhaps a little bit of an overwhelming table if you see it the very first time. So let me help you and walk you through the table and see what we got here. First of all, I wanted to note that everything you see in blue here are basically and green, by the way, are actually based on my own measurements or observations, and the other stuff we could kind of deduct otherwise from what's going on in the device. Now, so we go all the way on the left of the table and we see here that the device has 3 different modes: photography, video mode, and an endoscope mode, which is the endoscope that is delivered with this particular version of the device. And the photography mode basically is a 3:2 ratio mode, and the video mode is basically a 16:9 mode, whereas the endoscope is approximately 4:3, but not exactly so. Now I must note one thing, that for the photo mode, actually not all the settings, all the modes that you can choose are actually 3:2 modes, but I'll get to that level of detail a little bit later with you. Now then the next thing is the focal length of the lens here, and the focal length when we are in photography mode is being reported as 2.8 millimeter if we at least look at the metadata in the EXIF file. But if we actually compare it to the focal length of a 35 millimeter full frame photo camera, it will be equivalent to about 400 millimeters, so a fair amount of tele-lens. In the video mode, the focal length information is not part of EXIF, but I'm assuming it's the same lens here. But actually, because we got another ratio here, the actual magnification is, or the equivalent focal length is 350 millimeters. And then finally, for the endoscope, is rather a different story. It's about a 50 millimeter equivalent focal length. Now, then I want to look a little bit at how much distance, of how big a particular object is actually being shown on full screen, and also the magnification and the clearance, the room that we have between the ground floor of the device where the object is and the lens. And this is also relevant if you want to do some work on there, like soldering type of work. Now, the thing is that this is all going to be comparing a little bit about how you're going to mount the device. So we got it here. We can go up and down. There is a fine adjustment, but there's also a large adjustment. It's not super convenient. I'll get to that in my later videos here. So this is the clearance basically that we're having here, and I'm trying to understand the lowest and the highest setting. But here we have to see also what we do. So the highest setting for me in this version, if we take the device and we bring it all the way into the highest position here, actually to show that to you, I have to take the endoscope away, and this will be the highest position at least of the stand that is included. Now, if we want to get even higher than this, what we could actually do is mount the screen on a little bit different position here, because there are actually 2 places where you can mount it and you can still use the focusing ring, and we get more clearance. So we got 2 different situations here that I'm denoting here in different lines here in my table. So that is the A and the B. And what I actually found super surprising with this device, this lens can not only focus on the type of distances that we got over here, but actually we can also just focus it on infinity, like a photo camera. To me that was a large surprise. I never expected that, but it actually allows us to do a couple of things that we'll get into later that are very, very convenient. So I also measured the device performance when it comes to that. So we're going to have now this ABC lines here, and these ABC basically going to tell us where the device is mounted in the lower part here. Is it mounted in a higher part here, or are we putting it on the tripod or something else, and are we using kind of infinity type of thing here? Right, so the object width, I don't want to spend too much time on this, but in this table basically you see how big an object is being shown full screen. So we can basically use a simple ruler and able to calculate that, but we can also do that in a couple of other ways. So this depends on the mounting and also on which mode you're on. That basically results in a magnification mode, where we compare the original and then we compare it basically to the size of the screen. Oh yeah, there was an issue about this magnification here, because I've seen like really high magnification numbers being mentioned, I think both by the manufacturer and in a number of YouTube videos. But apparently for this magnification, they kind of assumed that you're showing this picture on a 42 or 100 inch LED screen or so. I think that didn't make a lot of sense. So with magnification, I'm basically here looking at the magnification, how it is if we look on the internal screen of the device. And obviously you can make the screen bigger by putting an external screen to it. Now, I already talked a little bit about the clearance of the object a little bit. So here you basically see the distances that you can set. And as you can see here, I also noted a couple of numbers here in green. Why is that so? So these lower numbers you see here, the 55 millimeters, that is not because we cannot bring the device down enough basically, but simply the device won't be able to focus anymore if we get closer to 55 millimeters between the end of the lens barrel and the object. So that is the minimal clearance that we need to satisfy here. And then finally, the aperture, at least if we take that from the EXIF metadata, is 1.8. There are ISO settings, at least in photography mode, 100, 200, 400, and automatically. In the video mode, you don't have any sensitivity settings, and the endoscope, actually, I'm not entirely sure. The coding is fixed. For photography, we also always get JPEG coding, and for video, we always get an H.264 coded video signal, an MPEG-4 AAC, which is in an MP4 type of container. And then here we got the actual resolution modes and video modes that we can choose from. That's what you already saw in my earlier sheet here. And so there's something particular about here that I want to highlight here, and that is the 2M HD mode here, because that is in the list of photography modes, is in between these regular type of photography modes, but there's something curious about it or different about it, because actually that mode is not a 3:2 mode, but it is actually a 16:9 mode. So in terms of the object width and magnification and clearance and all that things, etc., it actually follows the specification that I show here for video rather than those for photography. Now, as you will later see in my video, this really matters, because there are some things we need to consider when we look at this ratio, and also when we want to understand the full resolution here of the device. Now, getting a little bit more to the photography quality of the device. So I started off by putting some objects under the microscope and making a bunch of pictures of them. And my first visual impression here was that actually it doesn't matter really a lot. I don't see a whole lot of difference between all the different quality settings. Only when I go down to very low resolution settings like VGA or the 1.3 megapixel mode, then I clearly see some degradation. I'm making a little bit bigger here so you can get a little bit of an idea. On the left hand side, we see the 24 megapixel picture. On the right side, the 3 megapixel picture. I acknowledge that when you look at this video now on YouTube, you might not be able to pick up the exact view that I got it here on the screen, but I visually see very little difference here. But nevertheless, probably want to approach this in a little bit more systematic way of doing that. And how do we do that in a more systematic way? I figured out, why don't I do that in the way that we regularly do that with photography cameras, because this device can focus on infinity anyway, so we can just test it like any regular camera as well. and we will then be assuming that its performance will be the same, you know, on the focusing distance of 3-4 meters or so, as with the other mode. And I'm fairly confident we're not going to see big changes there, because the limitations are actually somewhere else than into this focusing distance. So we should be okay there. So now how are we going to do this resolution measurement here? I'm going to use my resolution test cards here. Let me see, get them somewhere over here. Yeah, these are my resolution test cards, and they're called RES7 set of test cards. Actually, the real test card is hanging here on the wall. This is just the documentation. That's all fine. So these type of test cards are pretty well known as the ISO 12233 standards. That is a rather demanding, high quality type of test. The test cards for the ISO standards are also fairly expensive. I think you easily pay like 250 euros for the cheapest version of that test card. It's a nicely printed card, a very high quality print. What I'm using here instead is what we call a RES7 test card, and that is a much more affordable type of card. I think I paid about 20 euro for it. But for undemanding type of things, if it's more like an indicative type of exercise, I'm perfectly fine with these cards. And these allow you really at a lower price level to get some indication of resolution management. Let me mention right here as well that anything I'm going to show to you from now on basically is going to be indicative. They are done with this RES7 card, they're not done with ISO cards. There's some degree of own interpretation of the data. And if you want to do this in the official way, actually you have to take a number of steps in terms of repeating the images, in terms of focusing, in terms of lighting, etc. That I all didn't go through. Again, I feel confident that the limitations that we're looking at here today are such that it doesn't really matter, you know, following this whole test procedure. But I just want to point out that the results that you see here today are at best indicative. But I think they're useful insights. So I've been hanging this test card. Actually, this is a picture of the living room where I hang the test card on a flat wall, and we actually see the microscope there with its lens facing towards the camera. Now, in order to, well, not calibrate things, but just to check whether we got everything correctly, etc., I decided first to do a run of resolution testing using my own photography camera. And for this I took the Nikon Z camera that I regularly use to shoot these episodes as well. And that is a well, fairly high resolution camera. I mean, it's a very good camera. I'm very happy with it. And it offers some, I think, 47 megapixels of resolution, at least theoretically. And I've mounted a fixed focal length, 50mm length, 50mm 1.8 lens on it. That is also a pretty good lens. So we should get very decent performance out of the camera in that way. And so I made pictures of my test chart, and then I'm going to analyze these pictures and try to see what type of resolution I observe. And I'm going to show you the result right over here. Out of these test cards, basically, we're going to use one particular part here, these lines that come closer and closer together. And we're basically going to look at the point where we can still see distinct lines. And again, I realize if you see this now all on YouTube, it might be kind of hard to grasp. And also in reality, there's going to be a bit of an interpretation thing here. But I've tried as good as I can to find the point basically where we cannot see the individual 9 lines or so anymore right here. And these are the things that I've indicated here with red little spots. Actually, you also want to do this actually with a piece of computer software, and there is a famous piece of computer software that can do this. It is originally written by Olympus Camera Company, and it was adopted by SIPA, a Japanese, I think, standards organization for photography. But I tried to find several versions of that software, and I could get not anything to work. Even on 4 or 5 older computers had around with all the operating system, I never got one copy to work. I mean, it used to work in the past. I see people using it in the past in academic papers and whatever. But I couldn't get it working in the last couple of days, so I just did this on visual inspection. But so what is the bottom line? We're trying to see here basically the number of line pairs, because that's what we're talking about here. And as you see in the column, the one but most right column here, is that the theoretical number of line pairs vertically that we should get with the camera is 2752, because that's exact half of the number of vertical pixels. And for a line pair, we need a light and a dark, and a light and a dark, etc. What I'm actually measuring is in the range of 2400 line pair for the combination of sensor plus lens. It's always going to be a bit lower, that's fine. So out of the theoretical 45 megapixel resolution, I'm seeing about 30. Again, it's indicative, so don't go and mail me and say it's somehow different or so, but I just wanted to test, can we see resolution in that way. I also did that when I put the camera to a medium resolution setting, so then it's going to act like about a 25.6 megapixel camera, and I observe about 21 megapixels there, 2000 line pairs, and also in its lowest resolution setting it's supposed to be like a 11 megapixel camera, and I indeed see something in the range of 11, slightly below it. So yeah, so we can see that if we do this type of test on a regular photo camera, that's how it comes out. Now, let's go and look now at the Andonstar microscope here. So I did the same thing here, and here you already see the magnified result for the 25M mode, and we're not talking at all about the type of resolution numbers that I showed you previously about. It's going to be much lower, so I'm actually looking at another part of the chart here, and I see about 700 line pairs vertically. The 800 line pairs I think doesn't meet the definition anymore. I don't have the full contrast anymore there between the individual lines here. So from the 700 line pairs, I can see there are 1400 pixels effectively vertically, and then if I take the ratio of 3:2, then I don't know also horizontally how many pixels I have in addition to vertically. So I would end up at seeing a resolution of about 2.6 megapixels or so. So I did this for all the different photography modes that the device supports. And here you're seeing, now, quite a lot of them. You're not seeing all of them because it actually also got like a 20 megapixel mode between 24 and 16. But in the end, it's all kind of same, and it would have fit on a single sheet here. So I put it all together here, and what we can basically see is that any of the modes between 24 megapixel and 3 megapixel are, and 5 megapixel, I should say, are kind of all the same thing. We always get about 2.6 megapixel of optical resolution here. So way less than the 24 megapixels that we've been seeing there. If you go to the 3M mode, actually we drop a little bit below. We get about 600 vertical lines. That is equivalent to 1.9 megapixels. Then this kind of interesting thing, this 2 million megapixels HD mode. So that is kind of a significant lower vertical resolution than the mode above it, 3M. But in the end, it has about the same amount of megapixels. And what is going on there? Well, actually, because it is a 16 to 9 ratio, actually we get a much wider picture here, so we effectively get more pixels, so more megapixels. And the real thing is what is happening here is that here we're actually getting something which is also the native ratio of the device, and that's where you want to be. That's you're going to capture all the pixels here. But unfortunately, it is not a native resolution, so we can get to the native ratio, but not the full resolution there. And we can get to higher resolution, but then we don't have the native ratio anymore. So we got a bit of an issue there. Yeah, and the 1.3 modes, and particularly the endoscope modes, are to be ignored, at least I think, if you want to try to make a picture of it, because the end quality is very low. Theoretically, it's very low, but I wasn't even able to measure it in the test chart. The test chart doesn't even support something of such low resolutions there. I also wanted to know, by the way, if you took a look at the overall test table, because there are a test chart, because there are all types of tests on there. I must also say that, you know, the lens behave, I think, quite well. I mean, certainly not worse than I had hoped for otherwise, etc. It's a lens that does not have any particular type of artifacts that we got here. If you see, for example, some other devices on the market in this price category, you see a significant degree of color fringing, for example, here on the right. That's a picture I took from a YouTube video, somebody reviewing the Akins HDMI microscope. Yeah, with Andonstar we don't have any of this type of stuff, etc. When it comes to distortion in the picture, when it comes to all other types of artifacts, it seems to behave reasonably well. Okay, I got to acknowledge that for a resolution of 2.6 megapixels is not that particularly hard, I think, to make a lens that behaves well. But we see worse performance in other microscopes here on the lens side. Now, in the beginning of the video, I showed 4 questions that I want to answer in this video, and I think we can now kind of go to answering the first question here. What is the actual optical resolution of the device when we look at the lens plus the sensor combination? And the answer is, I believe, approximately 3.5 megapixels. Because that is actually what we would get if I see the optical resolution in the number of lines I can measure, and assuming that we will be able to save that somehow in a 16:9 ratio, yeah, using all the pixels that the device has. Yeah, where a lot of people talk about the 24 megapixel device, this actually seems more like a 3.5, and then the sensor itself might be more like a 4 megapixel sensor or so. Am I disappointed? Well, not really. I mean, seriously, I did not expect anything near to 24 megapixel performance. But this is kind of what it is, and at this price range, I think it is not unreasonable. The actual resolution is not mentioned on the product page of the device. Of the manufacturer. Also the website where I bought it didn't say anything about the resolution. Later on, when I actually went into the user manual, I did note that the user manual actually does confirm it's a 4 megapixel sensor here. But that's yeah, that's only when you really get into the user manual, unfortunately. Now let me get right away to picture number 2. Which are the best picture and video resolutions for capture? So the best picture mode is basically none of them, and it's this that really disappoints me. Not the low resolution of the sensor, but the fact that we can simply not save all the pixels that the sensor is actually able to take. Because the highest resolution settings that we have all are 3:2 modes, and they basically throw away everything that is on the outer sides of the 16:9 sensor, because that is the native ratio of the device. And we only got this 2M HD mode in photography that actually stays on 16:9, but that one already compromises on the number of pixels. So we best use the 5MP mode, I guess. That is probably the most reasonable alternative there. But yeah, I'm really disappointed. Why is there no native output? I mean, for me, you could skip all this photography in the modes and just give me one 4 megapixel mode in 16:9. Just give all the pixels that come out of the sensor. And then we'll deal later with it, and we can crop or enlarge or whatever you want to do. And if you want to upscale, I mean, it doesn't make any sense to me, but if you want to upscale, you go and upscale. But really, Andonstar, leave all the photography modes out and just put out the pixels that come out of the sensor. What is the best video mode? I would say the QHD mode, because that is a mode that basically can still capture well, as much of the actual resolution in the device. It would capture around 700 line pairs there in vertical resolution. However, that mode only supports 30 frames per second. So should you wish to have a higher frame rate, then you have to go to another video mode, but that would compromise on the graphic quality, of the resolution, basically. And yeah, if you use the device just to look at, I would suggest that you always put it in, when you're doing in the photography modes, always stick to the 2M HD mode, otherwise you're just throwing away field of view, or any video mode, which is also 16:9. So in terms of live viewing of the device. Now next I want to talk a little bit about the number of frames per second settings that are useful. And first going to look at the video recordings in the device, and going to comment on these. And then later I'm also going to talk a little bit about what we actually seem to get in terms of number of frames per second on the device screen itself. And for our experiment, I want something that moves relatively fast, so I took a mechanical Swiss wristwatch. It's a Longines with caliber type L688.2, and as we can see here, it got a caliber that vibrates at 4 Hertz, so 4 times a second the whole movement is being carried out. So that's a kind of an interesting thing to examine that under the microscope. Okay, so what we're going to see here first is the recordings coming out of the camera at 120, 60 and 30. But I brought them into Final Cut Pro, and Final Cut Pro anyway has a maximum setting of 60, so that's not going to be a big difference. Now we see the same thing going on, but we're going to reduce the speed to 25%. And now we can already see that we actually get to see more in the 120 settings. We can see a much smoother movement than the 30 on the right hand side of the screen. And now we're going to reduce the speed in Final Cut Pro by a factor of 10. So 120 FPS becomes 12, and totally to the right 30 FPS becomes only 3. And here we can really see how we can benefit from the 120 FPS. We can really slow it down significantly and picking up type of movements and seeing them, etc., that we were not able to see before. If you look very well, you could see, by the way, some glitches going on just a moment ago. So you can wind back. Yeah, there we had another glitch in the 120 recording. Now, coming now to the answer of the question, what FPS settings are useful here? Well, obviously that depends on the desired mode settings in your video editing program. Most video editing programs you have to start setting a particular frame rate, or it might take the frame rate of the very first video footage that you put into there, and you probably want to think a little bit about that, how your microscope videos are going to kind of fit in there. If you really have the wish basically to slow down matter, you can use this HD 120 mode, which is compromising in terms of resolutions. You get significantly less resolution than what the device is capable of, but that's the only way to do it with 120 frames per second here. It also has a kind of a strange 20% zoom, it seems, or so, or around 20% zoom. I don't know exactly where it comes from. One thing to be very much aware of is that when I've been trying the 120 FPS mode, I had hiccups in the device and glitches. Not only on the screen, but also in the video itself. They typically appeared in the first couple of 5 seconds, a couple of glitches, then it ran for a little while without problems, and then after a while regularly the whole device suddenly freezes as well, and you needed to boot it again. The videos were generally saved, but not always successfully saved, as I recall it like now. So it is not a super reliable mode. And you probably see the screen going up. That's another thing. If you take the SD card in or out, the whole device just goes down. But okay. I'm using this SanDisk Extreme micro SD card with a speed of, well, I can't even see it here. That's why I need this microscope here. But this is a super fast card here. So I don't think the issue is the memory card I'm using. The device itself, I think its processing power or so does not really suffice to make a 120 video. So you might have to do a number of different shots and hope that you get a good one, which I actually did for some of the shots in this video. Now, yeah, talking FPS, how about the internal screen? It will have a refresh frequency in itself in terms of the panel in here, but with also going to be some processing stuff going on as well. So it's also kind of curious to try to find out what is actually the refresh rate that you get in the end as used when you walk in that device. And I made a little test on that. I did a little bit of a laboratory setup to try to figure it out a little bit. So let's go and take a look at that now. Okay, let's go and see the little measurement setup that we got here. Here we got the microscope, and under the microscope, and I hope you can see it, it's going to be tiny from the screen, there's a little LED flickering there. And it's giving a small pulse every second now. And that pulse is actually coming from the signal generator over here. It is set at 1 Hertz, and the pulse width is just 100 milliseconds, so 1/10 of a second. So that's the flash that we're seeing down here.
and that's being reproduced on the screen, of course, of the microscope. And as you might already see, there's a tiny delay between the moment this flashes and we see it on the screen. And that's of course perfectly fine, because it's going to take some time, you know, to capture from the sensor, to process it, and then to render it on the screen. So this is exactly as we would expect it. Now, we're picking up whatever is visible on the center of the screen with a small photodiode, and then with a little circuit that basically turns the signal of the photodiode into a voltage, and we're sending that to the oscilloscope here. So let's turn the oscilloscope on now. And what we see here, this is the signal of the LED, and this is the signal basically what we've taken from the screen. And as you see here, it nicely follows what's on the screen. If I would capture a little bit longer here, changing the capture time here, it's going to take a little moment for the scope to capture it up here. Yeah, so it moved away from rolling mode in this horizontal time base. And here we see exactly that delay going on. How much is that delay? We could use the cursor of the oscilloscope, but actually we can also visually confirm it's about the length of the pulse here. So it's about 100 milliseconds of pulse. It's not always a perfect shape, and you also see on the screen that the screen reacts a little bit in brightness if I do it this way. But this behaves perfectly fine, and we do nicely see the flashing LED back on the screen. But of course we're flashing at a very low frequency now, so we shouldn't be surprised about this. Let's go and see if the microscope can deal well with faster changing type of signals. In order to do that, I'll go to a more basic square wave. I'll take a square wave with a 50% duty cycle, and let me take a signal of 5 Hz. So 5 times a second the LED is going on and off. And then I'm going to examine again what we're getting here back from the screen, and that looks perfectly fine as well. It can follow every flash of the LED. So that means that the screen is, well, refreshing now. At least it's showing us a refresh at least 10 times a second, because we must see an on cycle and an off cycle of the LED. So we are successfully displaying at least 10 updates a second from here. Now let's see if we can push it a little bit further. So let's go to 10 Hz and see what we're getting here. Now that looks perfectly fine as well. It can basically, and let's change the time base, the scope a little bit. It can basically display each individual little flash of the LED without any problem. So 10 Hz, which means it's updated 20 times a second, is perfectly fine as well. Let's push it a little bit further. Let's go to 20 Hz. Now we are getting issues. Already on the screen visually is not looking that great anymore. I don't know if you can see that from the recording, but also here we certainly can see it's not able to show each update anymore, only each other update or so. So it's really struggling with the light flashing at 20 Hz. So it would need to update the screen at least 40 times a second, but it's not able to do so. Let's go down to 15 Hz and let's see if it can still capture 15 Hz. Yeah, it's capturing some stuff, but it also has some kind of side effects. And now it's getting really less. And is it coming back in some sense? Yeah, it might be coming back. Sometimes happened when I did this test before. So what I think we're kind of seeing now, that it is close to the same value as by which is refreshing, or a multiple of it, etc. So I think the screen is really updating itself at 30 times a second, and at 15 it is just kind of struggling around that point, and it might be just in sync or just out of sync, and then it would cancel everything out. So bottom line is that we might kind of go until 15, so 30 screen updates a second, but that is not super reliable. And if we want to stay in the safe zone, then we would basically need to stick to a maximum of 10 cycles, so 20 Hz or so, a cycle of on and off per second, and then it still behaves perfectly fine. I also tested the same thing with different settings in terms of video mode versus photography mode, and I also tested the different resolution settings, but really it's always the same. These different resolution settings for photo and video and frame rate only relate basically to the recording to the SD card, and not to what is shown on the internal screen. It's always going to be the same. Now we're on it, we can also test another little functionality that was initially a little bit confused about. And let me show it in that way. I'm going to choose a faster signal at 50 Hertz. He's not able to do full captures anymore, so we're not getting any each individual flash by far, but still we got a picture, we can see what is going on here. But I see a quite nasty type of flickering going on the screen. And what function I want to go to now, there's actually a function that is called frequency, and we put it to 50 Hertz, and look, the picture is completely steady. Now the function that you're seeing here, this is a function you also find often on photo cameras, and what it's basically doing, as I understand it, it is syncing the start of a capture of the sensor or so, basically with the 50 Hertz signal, so it's not always kind of capturing in a different point in time relative to a 50 Hertz signal, and that would cause this flickering effect. And you have the same type of compensation should it be 60 Hertz. So this is relevant if you're, well, if you're playing with an LED like me, but I guess not many people are doing that. But this will be relevant if you're not using the built-in light source, but if you're looking at something which is getting light from a fluorescent light or so, or something else that flickers, and then you might want to basically correct for that type of thing. So this 50-60 Hertz has nothing to do with the frequency of the built-in lights here, as was suggested actually by some websites that I was looking at. These lights just light continuously. Now finally, question number 4, does it make any sense to connect it to an external monitor? Because we got an HDMI output, as everybody in all the other YouTube videos already noted out, that if you use that output, the internal screen goes black. That is a bit disappointing, and it doesn't happen with other devices of Andonstar also, if I recall well what people said in videos. Well, gotta take it what it is, but just let's look at whether it makes any sense to have such an external screen for it for viewing purposes. So the internal screen is 800 pixels vertically. That's at least what the manufacturer specification say so. So the optical system, as we have talked about earlier in this video, can resolve around 700 line pairs, so 1400 pixels vertically. So that means that the device can capture a picture of a higher quality than the internal screen can show. So it might be worth looking at whether an external screen would give you a bit more of that. Now, if you connect an external monitor to the device, it seems that it will go at maximum to a HD mode, 1920 by 1080, 60 frames per second interlaced. So we're getting a higher resolution than the internal screen, but only slightly higher so. We go from 800 lines to we go from 800 pixels to 1080 pixels, but we don't go anywhere to the 1400 pixels that the device can show. So yeah, resolution wise I think is not really worth it. You get slightly more resolutions on the external screen, but not that many. Still, there might be other use case for the external screen. You might put a video grabber there that you analyze the HDMI signal and take that into a computer or into a hardware video HDMI recorder like an Atomos Ninja, which I sometimes use here as well, or the Atom switches, the Atom mini switches can record as well. So you might have other reasons that you might want to do that, but that's up to you. But resolution wise, yeah, not really. Okay, that brings me to the end of this video, and I think we spent a significant amount of time already trying to understand just the optical side of this device. Yeah, so 4 megapixel sensor, actual resolution more like 2.6 megapixels. Not what a lot of people have been talking about, and some others have accepted. I think actually it is rather realistic. I think at this price level, you're never going to have something that has a real actual optical resolution of 24 megapixels. Let's face it. And both the sensor and the lens have to be probably much more expensive than we can put in this type of device here.
Yeah, bottom line, I would still buy it. I'm having a lot of fun here with this microscope here, and I'll do another video where I'll talk about some ins and outs and also give a number of tips here. But despite the low resolution, I think it's a very usable device. It's a fun device. You get value for money. So I can still recommend it. But I hope this video helped you a little bit to understand also the resolution limitations and gave you some insight in what are your best options if you actually want to use this device to look at or to somehow capture the photos or video of the device. Okay, thanks for watching, and hopefully see you for later videos.